Nanotechnology is a new and emerging field. One of the first nanotechnology courses offered at URI is being taught this spring. In this course, the students have to complete a project relevant to the field of nanotechnology. In one of the projects, the students have to examine how nanoparticles respond to traveling through blood and then into water. To do that, the students have to create solutions that mimic these conditions and then test the nanoparticles with tools they became familiar with in the course.
I'm a junior here at URI. I study mechanical engineering, and nanotechnology is important to me because it's a field that has a lot of potential. Being able to manipulate things on a small level, that opens the door to innovation in a lot of fields. Something very exciting to be able to really control matter on a very small level. So for our project, we're looking at how nanoparticles move in, well, how they react to moving in the blood and then into fresh water. And so what happens when they move through the blood is that the nanoparticles, they've got electrical forces working on the surfaces that attract one another, along with proteins and salt in the blood. And so what can happen is through that electrical attraction is they can start to stick together. That's what we're testing in our project, to see how much they stick together. There are a lot of nanoparticles in use in the U.S., and that number is growing every day. One example is that they're used in sunscreen to make it appear more transparent. That way you don't have like this thick white lotion that you're rubbing on yourself. Another example is clothing, that a lot of nanoparticles are used in clothing to protect people from UVB radiation and also repel water, keep the clothing waterproof. And also silver nanoparticles, those are used in stuff like food packaging and bandages for their antibacterial properties, keep things clean.